Okay, so now let's look at pressure worksheet number 2. Specifically, we're going to start with problem number 1. Problem number 1 says 1.2 times 10 to the third kilogram of water from a flood comes crashing against your sliding glass door with an acceleration of 1.5 meters per second squared. The door measures 3 meters wide and 2.5 meters high. What's the pressure of the water exerted on the glass door? So again, let's make our no wanton formula grid that will help us organize our information. We know that it's 1.2 times 10 to the third kilograms of water. We know that the acceleration is 1.5 meters per second squared. We know the door is 3 meters by 2.5 meters. And we want to know the pressure. Well, pressure is force over area, and force is mass times acceleration due to gravity. So let's go ahead and work through this and see what we can figure out, shall we? All right. Let's first find our force. We're going to use a mass times acceleration due to gravity. F equals 1.2 times 10 to the third kilograms. That's your mass. Your acceleration due to gravity is 9.8 meters per second squared. 1.2 times 10 to the third times 9.8 is 1.176 times 10 to the 4 newtons. And that's good because you want force in newtons, so that's one piece of the information. The only other thing you need is area. Area is length times width, 3 meters times 2.5 meters, and the area is 7.5 meters squared. There's my two pieces of information that I need. Pressure is force divided by area. I'm making sure my units are right. Meters per second squared, that's a Pascal. So I have 1.176 times 10 to the fourth divided by 7.5, and my answer is 1.569 times 10 to the third pascals. So that's how you do question number 1. Now let's jump to question number 7. And question number 7 is similar to question number 1. Question number 7 says, at 7.5 times 10 to the first kilograms, a 7.5 times 10 to the first kilogram book with dimensions of 24 centimeters by 20 centimeters is on a table. What pressure does the book apply to the table? Okay, so again, no wanton formula grid, what I know, what I want to know, and formulas that relate the two. So I know I have 7.5 times 10 to the first kilograms. That's my mass. I know the length is 24 centimeters of the book, and the width is 20 centimeters. And I also know the acceleration due to gravity is 9.8 meters per second squared. I'm trying to find pressure. Pressure is force over area, and force is mass times acceleration due to gravity. So again, just like the other one, let's find our force first. Mass is 7.5 times 10 to the first kilograms times 9.8 meters per second squared. 7.5 times 10 to the first times 9.8, and that gives me 7.35 times 10 to the second newtons, and that's my force, and it's in newtons, so that's what I wanted. Now I'm going to find my area, which is simply length times width, 24 centimeters times 20 centimeters, and that's 480 squared centimeters. But again, this has to be in meters, not centimeters. So we have 480. Write it twice if you need to remind yourself that you have to do this twice. Get rid of centimeters, be left with meters. There are 100 centimeters in 1 meter. That gets rid of one of my centimeters. I still have one left. Get rid of centimeters, be left with meters. Again, 100 centimeters in 1 meter. So if I take my 480 n divided by 100, n divided by 100 again. My answer is 4.8 times 10 to the negative 2 meters squared. So that's my area. There's my force. Now it's plug and chug. Pressure is force divided by area. So it's 7.35 times 10 to the second divided by 4.8 times 10 to the negative second. And my answer is 1.53125 pascals. That's number 7. Number 8's a little more complicated. It's not necessarily harder, just more complicated. So let's do problem number 8. Problem number 8 says a reservoir behind a dam is 15 meters deep and the dam is 250 meters long. The total amount of water behind the dam is 7.5 times 10 to the 5th cubic meters. What's the total pressure acting against the dam? And they give us the density of water. Given that they gave you the density of water, that's a hint. Okay? So what we know, what we want, and our formulas. So what do we know? 15 meters deep, 250 meters long. We know that volume equals 7.5 times 10 to the 5th meters cubed. And we know density is 1.00 times 10 to the 3rd kilograms per cubic meter. I want to know pressure. I know that pressure is force over area. I know that force is mass times acceleration due to gravity. And I know that density is mass divided by volume. So, wow, we have lots of work to do. Okay, so the first thing we're going to do is we're going to find the mass. We'll find the mass, okay? So to find the mass, it's density times volume. Our density is 1.00 times 10 to the 3rd kilograms per meter cubed. Our volume is 7.5 times 10 to the 5th meters cubed. Meters cubed cancel out. That's good because I want to be left with kilograms if I'm looking for mass. So 1 times 10 to the 3rd times 7.5 times 10 to the 5th tells me that my mass is pretty big. 7.5 times 10 to the, and hold on while I count my decimals. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th kilograms. Lots of water. Okay, now I have my mass. From my mass I can find my force. Force is mass times acceleration due to the gravity. So it's 7.5 times 10 to the 8th kilograms times 9.8 meters per second squared. And that tells me that my force is 7.35 times 10 to the, again, hold on while I read this, 1, 2, 3, 4, 5, 6, 7, 8, 9 newtons. So I've got my force. Now I need to find my area. And area is length times width. So my area is 15 meters times 25 meters, 375 meters squared. That's good because now I've got my area and I've got my force. Pressure is force divided by area, 7.35 times 10 to the 9th newtons divided by 375 square meters. And I'm actually doing this on my calculator right now. And I'm wondering if I'm off by a factor of 10, because when I did this before I got another answer. So let's, it's 1.96 times 10 to the 1, 2, 3, 4, 5, 6, 7 pascals. Let me recheck this. 15 times 25. Nope, that's right. So it's 1.96 times 10 to the 7th pascals. Question number 9 is one I'm not positive I know right, so we're going to try to work it together, and no guarantees. Okay, for question number 9, no guarantees. So let's turn my page here where I made some notes to myself. All right, here we go. Let's try this. Number 9. It's about the hydraulic lift being used to lift cars. We're going to just start our no, want, and formula grid. I don't need to read it to you. You can read it to yourself. No, want, and formula grid. So we have diameter of the large piston is 22 millimeters. Diameter of the small piston is 6.3 millimeters. Force is 3.0 times 10 to the 4th newtons. So that must be force for the large piston. We want force for the small piston. Okay? So one of the things that I know is force times area is constant. So force for the large piston times area for the large piston should equal force for the small piston times area for the small piston. And pistons are round, so the area is pi r squared. And radius is 1/2 of diameter. Okay, 1/2 of diameter. So let's get started. What do I want to do first? Let me find the areas. Okay, area large, area small. Area large is pi times 11 squared. And again, that's 11 millimeters squared. So that is 379.94 square millimeters. Area small then would be pi times, I don't know what half of 6.3 is. Yes, I do. It's 3.15. So half of 6.3 is 3.15 millimeters squared. So pi times 3.15, whoops, times, go back, delete, times 3.15. Looks to me like this is 31.17 millimeters squared. Okay? Now I'm going to use this equation up here. So I want to solve for force of the small. Force of the large, area of the large equals force of the small, area of the small. And I want force of the small. So if I divide both sides by area of the small, I should be able to get it. So the force of the large, we know it's 3 times 10 to the 4th newtons. The area of the large is 379.94 millimeters squared. The area of the small is 31.17 millimeters squared. Get rid of your millimeters squared, you're left with newtons. That's good because that's what force is in. Let's see what we get. 3 times 10 to the 4th times 379.94 divided by 31.17 tells me the force of the small should be right about 3.657 times 10 to the 1, 2, 3, 4, 5 newtons. And my best guess is that that's right, but gosh, don't quote me on it. Check that out with somebody else who knows how to do this a little bit better than I do, because I'm not positive that I've got that one right. Okay? Number 10. All right, number 10. A girl is floating in a freshwater lake with her head just above water. If she weighs 600 newtons, what's the volume of the submerged part of her body? Okay, so let's do no, want, and formula grid. No, want, formula. A little too high, sorry. We know she weighs 600 newtons. And we want to know volume. But we also know density of water, because we did that in problem number 8. We did that in problem number 8. And the density of water in problem number 8 was 1.00 times 10 to the third kilograms per meter cubed. Okay? Now, the other thing that we know is about buoyancy. The buoyant force is what this is. We're going to call that buoyant force. And we know that the force for buoyancy is density times volume times gravity. And we want to solve for volume. So FB divided by density divided by acceleration due to gravity should give us the volume. Let's see if we're right. So we have 600 newtons. The density is 1 times 10 to the third kilogram per meter squared, per meter cubed. And gravity is 9.8 meters per second squared. I'm going to actually do the units in just a minute because I want to make sure they all work out. A newton is a kilogram meter per second squared, so that will cancel out. You're left with kilograms per second squared. You'll be fine. The units work perfectly. So we have 600 divided by 1 times 10 to the third. And then that answer is divided by, okay, hang on, that didn't work. 600 divided by 1 times 10 to the third. And then that's divided by 9.8. And I come up with probably not the right volume. Volume should be in meters cubed. So this is kilogram meter per second squared. That cancels, that cancels, that cancels, that flips upside down. Yeah, you get cubic meters. So that's what I got. I'm not positive that one's right either, so double check on that, but it should be okay. So that should be the correct answer for number 10. I will do the gas laws worksheet. I don't have any more time today, but I will get to it tomorrow, and I will make sure that you have that tomorrow. If you have any more questions, please let me know.